doing. So we are on question 22. The diagram below shows a sketch of y squared plus 3x plus 2 passing through the point. So now this question comes under calculus, okay, and I'm going to solve it very we'll take it very simple. Okay, so the first question says find the coordinates of a and b. So to find the coordinates of a and b, what we're simply going to do, we have been given this equation. Okay, so we have been given this equation that we have here. So what I'm going to do is this. So the equation of the curve is given like this: x squared plus 3x plus 2. So we're trying to find this coordinate and this coordinate. So in other words, what we are trying to find here, the coordinate for A, we'll start with the coordinate for A. We need to find the x-axis as well as the y-axis for A. Okay. The same thing for the coordinate B. We need to find its x-axis and its y-axis. So we're going to start with finding the coordinates for A. Okay, so finding the coordinates for A, you see that A is a point that is on the x-axis. Okay, and the x-axis here is also called y is equal to 0, and this is because that in this x-axis y is always equal to what? To 0. Okay, y is always equal to 0. So this is what we have. Okay, so now if we replace 0 in this equation, it will give us the x-axis of this line. Okay, so in this line y is equal to 0. So if we put 0 here, is equal to, we've said y is equal to 0, x squared plus 3x. Okay, so these questions just follow what I'm doing. So you have 0 here. Okay, so now this becomes a quadratic equation, and you can either use the formula or you can use the factorization method. So I'm going to use the factorization method here. I'm going to introduce p, which is a product, the sum, and what we call the two numbers that will give us the factors. So for the product, you multiply the number in front with the number there. So 1 times 2, your product is 2. For the sum, you get the number which is in the middle here, which is 3. The two numbers, we mean numbers that when you multiply them, okay, these two numbers, when you multiply them, should give you positive 2, okay, and when you add them should give you plus 3. So these two numbers, it's actually 1 and 2. Okay, when you multiply these, they should give you your product. 1 by 2, it is 2, and when you add them, they should give you your sum, which is 3. Okay, so this is what we basically have. So these are so the two factors, since the square of x here, x squared, the variable, I mean the coefficient is 1, meaning these are the factors. So we're just going to write one factor is going to be x plus 1, and the other factor is going to be x plus 2. Okay, so remember these have been equated to what? To 0. So I've factored out, I've factorized this one using factorization method of quadratic equation. So here is what we have. Okay, at this point now, what you're going to do is to split them up. So it's going to be x plus 1 is equal to 0. Then you say, or x plus 2 is equal to 0. So you take the one this side. So x is equal to negative 1. This one, x is equal to negative 2. So now what we found here, it even makes sense. Okay, we found these two values. because we said in this line y is equal to 0, so it has given us these two values, and by looking at them you can tell that this one is where the -1 is, and here is where the -2 is. So the coordinate for this one, we found it, it's -2, 0, because y is 0. So the coordinate for A is basically -2, what, 0, and you're good to go. Okay, here is what you have. So this is the coordinate for A. Now find the coordinate for B. This line called the y-axis is also called x is equal to 0. Okay, it's called x is equal to 0. So x is equal to 0, so meaning that when we get the main equation, we substitute for 0, we are going to get the y-axis, which is this b here. So when we say y is equal to, now we are replacing everything for x with what, 0. So it's going to be 0 squared plus 3, and then 0, then plus 2. That will be y is equal to, everything will be 0, so y is equal to 2. So the coordinate for B is actually, remember in this axis x is 0, so it's going to be 0, 2, and these are the coordinates. Okay, this is the coordinate for A, and this is the coordinate for what, for B. So I hope this is clear enough. You can rewind, okay, pause the video and try to solve the question on your own, but this is what we were supposed to find. Okay, these are the two coordinates. Let's go to finding the minimum turning point, which is very very important as well. Okay, so for the minimum turning point, okay, for the minimum turning point is what we are going to do. Okay, so the minimum turning point, this is the equation y is equals to x squared plus 3x plus 2. So here we are going to find the minimum turning what point. So to find the minimum turning point, we are going to write the equation. So our equation is y is equal to x squared plus 3x plus 2. Okay, so now that we have this, let's do this. We're finding the minimum turning point, and I'll be a bit slow here because I want it to sink. Okay, so this is your equation. So the turning point, now what do they mean turning point? So the turning point is where the curve makes a turn. So this was the turning point. If it comes like this is the turning point. So where the curve is actually turning, that is your turning point. So in this case, they want you to find the point here when it is actually turning. Okay, but before we go into turning point, let me explain. Okay, so what we call the turning point, I'll call it TP. So at the turning point here, when you have a curve like this, it has two turning points. Okay, there's a turning point here, and there's another turning point here. So the question here was specific on saying minimum, because when it's a hill, this is a minimum turning point, and when it's a hill going up, so this is a hill, and then this is more like a depression. Okay, so on a hill, this is called maximum turning point, this one is called the minimum. Okay, so this one is the minimum turning point, and this one is the maximum turning point. But for this particular curve, it only has one turning point, and this is what, a minimum. It's a minimum turning point. Okay, it's a minimum turning point. I'm sure I understand now the difference between minimum and maximum turning point. Okay, now that we know the difference between minimum and maximum turning point, let's now see how we can find this. So to create a background here, there's what we call gradient. Okay, there's what we call the gradient. So the gradient refers to the slope of the curve. So you can see this is a slope, or this is a slope, also this is a slope. Now this is a positive slope because it's going up, so there is a positive gradient. This one is coming down, so it is a negative gradient. Okay, but at the turning point here, there is no slope actually, it's horizontal. Okay, a slope is something like this or like this, but if it's straight here, your gradient is 0. Okay, so meaning at the turning point where it turns, the line becomes flat like this. So this means that at this particular point your gradient is 0. Okay, your gradient is 0. So this is what we have to bear in mind, that on the turning point, the gradient is what? The gradient is 0. Okay, the gradient is 0. So we're going to solve this and explain it in a very much better way so that you can get it. So here's how you're going to do this. Okay, so this is our equation. So what we want to find is the turning point, and we've already said that at the turning point, okay, at the turning point, you can say at the turning point, okay, at the turning point, gradient is equal to 0. Okay, gradient is equal to 0. So in calculus, how do we find the gradient? We differentiate. Okay, that's how we find the gradient in calculus, by simply differentiating, finding dy dx. So we are going to find dy dx. So finding dy dx, if you don't know how to differentiate, please, you can watch our previous videos on differentiation. We're going to go into details. Okay, so under differentiation, this 2 comes here, so it becomes 2x. Let me write that nicely. 2x. Then this you reduce by 1. Okay, so if we can't put a 1 here, we'll just leave it. Then plus. And then at this particular point here, differentiating this, whenever x is raised to the power 1, you just drop down the x. So differentiating this will give us 2x plus 3. Okay, so we've just differentiated. We are just finding the derivative of y with respect to x. Please watch the previous video. You can leave a comment section. I can send you the video in the comments so that you can see how differentiation is done. I don't want to go into details in differentiation. The video might take hours and hours. Okay, so we've differentiated this. Okay, so we can't differentiate a constant. That's why I've left it here. It's 0. So now that we have this, okay, so this is the gradient function. So the formula for finding the gradient now is this. Okay, 2x plus 3. Now remember what we said, at the turning point gradient is 0. So we're going to say at the turning point gradient is 0. So you solve for x now. Okay, so this, you can take the 3 this side, and this is going to be negative 3 is equal to 2x over 2 over 2. You cancel this, so x will give you negative 1, 1, 2. Okay, so now this is the x coordinate for the turning point. Now you need to get the y coordinate, and to get the y coordinate, here's what we are going to do. We just increase the ink for this, maybe just up to here. Okay, so you're going to go back to the equation. Y is equal to x squared plus 3x plus 2. So to get the y now, because we found the x value, So we're going to replace the sign. So this is easier to replace. Let's replace negative 3 over 2. So y, since we did this, so we can say negative 3 root of 2. I'm replacing it for x, then plus 3, negative 3, 2, then plus 2. Okay, so we are going to get this negative 3 squared, that will be 9, 2 squared, that will be 4, plus 3 by 3, that would be negative 9, then 2, then plus 2. So you're going to have, I can take the 2 this side, it becomes minus 2. Then here I'm going to remain with 9 over 4 minus 9 over 2. Okay, so I'll solve this as a fraction. Common denominator is 4. 4 there, 1, there you get 9. Minus 2 there, 2 times 9, 18. Okay, and then remember here we've got y minus 2. Then you cross multiply. So 4 times y, you get 4y minus 4 times negative 2, get negative 8 is equal to this one times, so 9 minus 8, that's negative 9. Then this is going to be 4y is equal to negative 9. Take the 8 this side, plus 8. Okay, then that will be 4y is equal to negative 1 over 4 over 4. So this gives us y is equal to negative 1 over 4. So this is the other. So negative 1 over 4. So this is the coordinate. It's a bit tricky, but it's possible to find. And here's what we have. So that is the coordinate now for the what? For the turning, the minimum turning point. Okay. This makes sense. They should be both negative. Looking at how the graph is, they should be both negative. Okay, so this is what we have here. Okay, it makes sense. So the coordinate that is here, and the x here, that is negative 1.5, which makes sense because at first we had found this one as negative 1, the previous question, and this one was negative 2, which makes sense this to be negative 1.5. And this one is just a quarter. Okay, it's just a quarter, this one, which is negative 1 over 4. Everything is making sense. So this is the minimum turning point. Okay, let's go to question B. Solve the equation 81 minus 27 to the power x is equal to 0. Okay,